This is our last topic in wood, and this is fasteners. So basically connection details. As you know, there's pretty much versions of nails and screws, and then some other kind of specialty plates. This was already in your packet, so here we have it. Um, Bolts, particularly for structural type connections of timbers. Split ring and shear plate connectors, which you may be less familiar, very much a structural application. Tooth plates we talked about in the trusses, and then a lot of times we're attaching metal to wood, so how we do those attachments, and then there's obviously things like there's machines to drive staples, nails, you name it. And actually, adhesives are another piece of we can use for fasteners. All right, so mechanical fasteners. This is in chapters 11, 12, and 13 of your NDS. Okay, so there's general connections, dowel type fasteners. So they aren't talking about the dowels that you get with a cheap piece of particle board furniture at Walmart. They're talking about anything that has kind of that dowel like a nail, bolt, lag screws, things like that. Split ring and shear plate, those are advanced connectors, but I'll show you what they look like. The majority is going to be some form of nail or some form of screw. When nails, when screws, nails are cheaper and faster. Screws are used when you, let's say, when squeaking, they're tighter. So like on a floor or a component where you want to make sure that that's not going to loosen, right? So basically, a nail is a sharpened metal pin. Nothing exciting there. You use a hammer to nail in a nail, or you can use a mechanical nail gun, which you'll see very frequently on construction sites because it's much faster. And sometimes, it's a bit of an art to drive a nail in a minimal number of hits, particularly if you're working with some pretty hard wood, like, very aged oak and things like that. There's common nails, finished nails, and then some other specialty types. It's actually a funny cartoon. I heard a loud bang and he was gone. Haha. All right, engineering humor. Um, Common nail. So you go to Menards or Home Depot, whichever you prefer, and if you haven't done projects yourself, you can kind of take a look at the array of nails and screws that are available in the kind of hardware sections of these stores. Um, there's common nails, box nails. These are designed so the head obviously is flush with the surface of the wood, right? If you are using a nail gun and you overdo the air pressure, it'll divot down into there. But the idea is to have it flush with the wood. Um, Common nail is what we use for kind of for framing. It's a large hardy nail and it comes in different sizes. The box nail is a little smaller shank. If you can use this, it's a little bit it doesn't split the wood as easily because it's got the smaller kind of dowel piece here. It's good for smaller wood applications, shingles, although you also have roofing nails, shingles, and just casings that are more rough casings where you don't need a finished look. Casing nails are when you need a finished look. So now we're moving into kind of finishing nails, which are these guys here, where we're trying to sink this so that we don't really notice it or see it. These also can be done with guns. I've worked on some projects here at my house, and I don't have a nail gun, but I have a finishing nail and a brad gun. So the finishing nails are good for putting on my big trim pieces. The brad nail gun is good for putting on pieces that are attached to the trim pieces, um, or some furniture applications and things like that. Right. So these are the small little ones, and you can go back and make sure they're finished off correctly so that you don't notice them right away. So you'll see this on trim work. A deformed shank nail, this is once this thing is in here, it's very hard to remove. So this is not like you pry out like a common nail. So it's a tight fastener. Hardened concrete nail is when we're attaching to masonry or concrete. It's a little different application. Cut nail, I haven't seen these quite as much. So if you're doing the wood flooring, it's got a square head, and this shape reduces cracking. So you might see this used in wood flooring when you're not using the plank type systems. And then a roofing nail, and the roofing nails are short and have a very large head on those. They're used for, and sometimes they'll have like rubber washers and other things like that. Um, You'll see tons of these, and they're used for roofing. There's one other kind they don't show on here that you might be curious about, and I'm going to draw it poorly. It should look, well, here. It should look like the common nail, but if it had a second head here. What those are duplex head nails. They're for temporary construction. In other words, if I'm just putting up some temporary frames or something, a scaffold or something to hold things up. If I use these, obviously what I'm doing here is it stops flush with this head, and then this gives me something to grab the hammer onto. So if I know I'm going to come back and take something out and it's just temporary, those things are pretty handy. All right, nail sizes. So they're called penny, how many penny nails, 10 penny nail, etc. And that was originally because you could get a bunch of them for pennies. Okay, so nothing too exciting there. And you can see how this runs from 12 penny nail down to 2, and this shows you some of the lengths. So this big 20D is a 4-inch long nail down to a 1-inch nail, penny nail. Here's my 10 penny nail. And again, we talked about this, but there's common, box, finishing, etc. And we talked about all these guys too. All right. Oh, here's the double-headed nail. And tacks. So tacks for small things. We put those on the bulletin boards, but they're also good for attaching smaller components or thinner components. Here's some in kind of real life. Here's that roofing nail, right? A finishing nail, you see how that head looks a little bit different. Spiral kind of grabbing nail, deformed nail. And then we've got a galvanized versus a sinker. And let's talk about coatings a little bit. Well, size, yeah, we already talked size. They're measured in pennies. So you'll have either a bright nail, which is uncoated and plain. You can have a zinc coated nail, so a corrosion resistant nail. So that's basically galvanized. Zinc coating is galvanized coating. And then you'll see, particularly for decks, the resin or vinyl, although we use more of the resin or vinyl screws in those cases. But there's a resin vinyl nail that actually, as you hammer it in, the heat melts the coating in. So that's a nice protection around that area. Okay, so that keeps us, when you have an indoor application, these bright nails are fine. If you have a outdoor application, you don't want to see a lot of rust spots or rust out your nails, the ones with coatings. That's why we would use that. Okay, anchorage. Nailing two boards together. Clearly, I'm nailing perpendicular to the grain through both of them. If I'm doing this type of thing, then end nail, this would be, for this guy here, is parallel to the grain. And as you can imagine, the wood behaves differently. And then what we call a toenail, where you're actually nailing in at an angle. Okay, so angle to grain. And how effective you are at doing that decides whether you completely miss the toe or close, or, that you got to get this angle pretty good to actually attach into both components. Okay, we'll just leave it at that. All right, machine driven. You can see these guys come for a nail gun. It's typically air gun or an air supplied, or you can do battery power or electric nailers. But you still hear the psst because it has the air push of the nail. So we see these in both horror movies sometimes. I just saw one the other night on Friday the 13th. So that, or actually on construction sites. And there's different sizes, and you have to have a gun that can handle within the size range that you're trying to shoot, which is why you'll end up with a smaller brad nailer or finish nailer or framing nailer. There's also staples that are effective for, if you're putting, for instance, uh, the coating over an exposure, though that's really nicely done with staple guns. Um, yeah, the nails come prepackaged. They're pretty fast. That's improved in productivity. Um, and so, I encourage you if you haven't already worked construction or done housing projects, it's something interesting to do, and it really helps you appreciate beyond just doing engineering on paper. Even if you're just making wood projects or doing some small things later in life when you might have a house or upkeep and things like that, it's it can be a good hobby, but it's also really effective in helping you understand how stuff really goes together and what you have to think about. So, encourage you to do that, or if you have a chance to work with someone, just be careful. Nail guns are dangerous, all these saws and things. You just need to make sure you're trained on the tools that you're using. All right, wood screws. So if you go in, you'll find into the hardware store, you'll find all kinds of wood screws, metal screws, in other words, for metal, for masonry, for concrete. So here's those deck screws I was talking about that are coated. There's different types of heads for the screws. So we've all seen, you've probably seen the Phillips types heads as well as the flat head. There's these ones, and this is not the only shape. You'll see these a lot on deck screws. It can be a square shape, different sizes. There's stars, all kinds of things. And then you've got these guys here that look more like a bolt. Okay. They're different type of installation, obviously. You can use a screwdriver or a driver, or you can use an electric drill with a driver. These guys, and a lot of times an impact driver, they have a lot of holding power. They can be removed as long as you don't strip them, and have many uses, basically. We also have lag screws and drywall screws. So lag screws are really large ones, and they will have that square or octagon type head, and those are actually installed with wrenches. They're too big, or a ratchet is a possibility. Drywall screws, these are the little guys made especially for screwing drywall onto boards, so we don't nail the drywall on, we use drywall screws. Bolts. So these are for your heavy duty structural connections. Like if you look at an old timber bridge, they'll have bolts. And so you have a pre-drilled hole rather, and the bolt goes through that, and then you use washers on either side, or at least on typically the nut side. So the bolt, the nut, the washer. This is a machine bolt. This is a carriage bolt. See the head difference here? Okay. You could spend hours and hours in the bolts and screws aisle at the hardware store and see all the different types of materials and coatings and sizes and shapes. Okay, so here's a bolted joint. In this case, here's your nut and your washer. If we're bolting two pieces together, this is a bolt, and you see the little square head here that keeps it from rotating once it's in there. You can apply, these things tight, they won't wiggle loose. Hopefully, there are different types of washers that are lock type washers and things like that, right? So of course, that's what it looks like on the other side. So if it comes with kind of a head that distributes load, great. Otherwise, there's washers. Split ring connector. We're not going to design these. This is for when you have a structural application and heavy duty shear. So it's basically a bolt, but there is a metal ring component that this is it's inserted into the wood, and it has a pre-drilled area, right? So if you looked at this side, there's one down here as well. So that provides more than just having a bolt through here. You've got the bolt plus this to transfer that shear load between this and this guy. It's called a split ring connector. Tooth plates. We talked about these. These are really effective at what they do, which is provide these truss type connections. They're used a lot in trusses for both roofs and floors. They're pressed into the member and they're very effective. Sheet metal, there's different devices made of sheet metal. These are really common, these kind of framing anchors. If you look in your rafters or if you look above the drop ceilings in a house or in a porch or something, you'll see these types of connections, particularly for these big framing members. Here's one that's framing in, but then also has a hold down. And then finally, adhesives. We use those a lot, obviously, in glue lamps and things like that. But they're also handy for, sheathing and some other on-site uses. And then, of course, if you're doing flooring or some of these other things, this is where these show up a lot. Subfloor deck adhesive, general construction adhesive has a lot of uses. All right, so let's look at how the nails connect. Right, so if I'm looking at a nail and I've got these two boards and I'm pulling in these two directions, I know that's going to cause a shear here at that face, right? The nail is providing all the resistance to that shear. So it's considered a dowel, this piece. So this connection has one shear plane, one place where it's trying to basically pull the nail in two directions. So this is the holding member, and this is the smaller side member, is the way they'll define this. Okay, so this is a single shear or two-member wood-to-wood nail connection. You can also do a similar connection with wood to metal, steel plate on wood, right? Bolted connections, same deal, except for now instead of driving a nail or putting a screw in, I have drilled through. I have a full bolt through that cross section. I have one shear plane here, or I could have this set up where I've got two and one central one. And then I've got two shear planes to divide that. Okay, so that's going to come into play when we design these. Here's a lag bolt. Okay, same idea. Single, this is single two-member. Here's a split ring connector. So what happens here is this ring comes through here and that helps transfer. So just instead of just having the bolt, I've got this whole shear ring that is helping me transfer this load over here. In other words, to resist the shear. Split ring, shear plate connectors that fit into pre-cut grooves. Okay, we're not going to design this one. All right, dowel type fasteners basically are cylindrical. They act like a dowel. This is your nails and things like that. The current code uses what's called a yield model to figure out the capacity. And these fasteners obviously bear against the wood of the member. So we can determine the capacity of these guys. There's plenty of testing out there, but we can mathematically determine the connection so that we can design the connection. If you don't have a connection that matches one of the ones that have been tested, you can either change it so you have one, or you can try to extrapolate the capacity, but it doesn't always work that directly. Okay, so you really know better if you're actually using one of the connections that's been evaluated before. All right, so we've shown single shear, but double shear is also very common, both with wood to wood and metal plate connections. Shear demand is perpendicular to the length of the fastener, right? It's the fastener, and you've got this joint where you've got pulling in this direction, this direction. So perpendicular to the length of the fastener is where we have that shear demand. Z is a term used in the code as a reference shear value for a fastener with a shear load. And then, of course, because that's the wood code, we have an adjusted value. Current method, for the method that we use now, we look at different types. There's the yield method allows us to look at different types of fasteners other than what's been tested and take into account and actually calculate this stuff. And we can also look at how that's affected by different species of wood. There are some pretty cumbersome equations. So if you go into your NDS and look on page 83, you can see some of those equations. All right, so dowel fasteners and shear. You can determine shear strength by the yield line equations, look at the exact yield value, and then get your adjustment. There are online calculators. There are tables that you can use for many of the common types of connections. So in NDS, tables 12A through T. Those are using the complicated equations and plotting them up for you. So they're design tools. So they use that yield line approach. They just to determine the Z value for the connection and then adjustment values. Dowel type fasteners continued here. So the main thing we have to do is the Z, or the dowel shear strength. So it's not, they're not using V, they use Z in this connection. The diameter of the fastener is D, large D. There's the bearing length of the dowel, which is the part in the wood. There's the bending yield strength, fastener bending yield strength, FYB. Dowel bearing strength, F times E. They used to call this the embedded strength. We've got the specific gravity again. We've got angle of load to the grain, the size, diameter of the fastener are all things that the bearing strength depends on. And if we have a metal side place or an anchor bolt embedded into concrete, it's the FE of in the metal or the concrete in that case. All right, so you add a M or an S to the terms to indicate whether you're referring to the main or side member. All right, so if you have two members, the main one is the thicker member. If you have three members, let's say they're all the same size here. In this case, the main one is the central member, okay, which often is the thicker one. For a nail or lag screw connection, those are mainly going to be the two-member connections. So we nail one board to the other or put a lag screw in. The member that has the pointed part in it is the main member. So let's say I've got two here and they're nailed or lag screwed together. This is the main member in that case. Okay. For bolted connections, the thickness of the member and the dowel bearing length are the same, right? So over here, you can see it's only bearing where there's wood. There's parts of the thickness of the member where it's not bearing. Same with the screw. Right? So less than the member thickness if it's a nail or a screw. Here's a bolt connection. It's washers or what have you. Here's a nail or screw connection. So the bolt connection is the thickness. The nail or screw is the length of the screw that's in the member. The bearing strength is greatest when the load is parallel to the grain and weakest for load perpendicular to the grain. So that's nothing new. Small diameter fasteners, okay, which have the same capacity, they have the same capacity regardless of the angle of load to the grain. Okay, they're small enough that they're not actually putting that big a hole in the member, or are they reaching that far? Okay, so we call this the withdrawal connection, and these are ones as shown here, right? The wood, if the wood is going in this, and this is, so now we're looking at, instead of putting two parallel boards together, right, like we were doing, now we're going to look at the connection where we're pulling in this direction and then this direction. So directly pulling this connection out instead of the shear piece. So we need to know that's the controlling, is this pull out of the fastener. So the force is parallel to the length of the fastener. In this case, instead of Z, we're looking at W, the withdrawal load, and the adjusted design value, W prime. Okay, so chapter 11, mixed fastener connections. talks about single fastener connections, and then those are in 12, 13, 14. So this just goes through kind of the basics of fasteners. You start with chapter 11, and this is the Z or the W. The adjustment factors. So we've got the three that are the same for sawn lumber. We've got a group action factor. We've got a geometry factor, end grain diaphragm, and toenail. Okay. We'll go through this when we do examples. In chapter 12, this goes through the dowel type and these yield line equations. I mentioned these tables before, A through K. Okay, so they give you wood to wood dowel shear connections. So parallel, perpendicular, and then side member, main member. It's if you're using wood to steel connection, it's based on the grain and the wood. Local stresses and fastener groups. So this is when we have, before we're talking about shear capacity, failure of the dowel itself, the metal component. In our case, we're using all metal components. Failure of one fastener and then adjustment factors are to supply. If there's a fastener, so we've got just that one failure, or we've been looking at that member failure itself, that nail or whatever failure itself, the fastener. If it's loaded parallel to the grain, we also need to look at the wood failing out at the next section or tear out. So if you've had steel, which a lot of you probably have, that's that net section tear out. Okay, and we'll look at that when we do an example. Okay. All right, so we're going to start with example 6.1, and that will be in a